It is certainly not going to surprise anyone here, and hopefully it wouldn't surprise anyone anywhere, what the neighbor discovery protocol's main purpose is, but there's a little more to it than just knowing it's for neighbor discovery. The neighbors we're talking about here are actually two groups of neighbors. We have other hosts and we have routers. And the processes for router discovery is different than the process for host discovery. So we're going to start with finding our routers. And this involves something called a router solicitation message. To start the router discovery process, the host sends an RS multicast onto its local link. The destination is FF022, the all IP version 6 router's address. That address should sound familiar because while we haven't talked about it much, we've seen it a lot. Whenever I've run show IP version 6 interface, we've been concentrating on the link local address and how that got built and the global unicast addresses and so forth. But I did mention at least once, hey, we seem to have automatically joined some groups here that we did not explicitly join. Well, we know now what one of those three groups is. FF022 is the all IP version 6 routers group. You join that on a router as soon as you enable an interface with IP version 6. So we've got that. Now the primary value the host wants is the link local address of any version 6 router on this link, but there will be more information in the hoped for reply than that. That's a little bit of a teaser. We're going to come back to that. But right now let's stick with the RSRA, because then any and all version 6 routers on the local link, they're going to hear that RS and they respond with an RA. Now that advertisement can have one of two destination addresses. If the querying host already has a version 6 address, well, that would have been in the router solicitation message as the source, and the router will unicast its RA right back to that address. If the querying host does not yet have a version 6 address, the source address of the router solicitation is going to be all zeros. And in that case, the router will multicast the RA to FF021, the all IP version 6 nodes address. And that, of course, looks very familiar to us because that's right on top of FF022 on our router in the joined group addresses list. So now we know, and these are two excellent groups to have memorized as far as their addresses, FF021, the all IPv6 nodes address, and FF022, the all version 6 routers address. Now, our routers are busy, but they're not just sitting around waiting to be asked for this information. On occasion, they're going to multicast it onto the link without receiving an RS. So it's an unsolicited router advertisement. And router saying, hey, nobody asked me, but here's my info in case somebody needs it. By default, the RA is multicast to FF021 every 200 seconds. Every 200 seconds. That's really all there is to it. And like I said, there's some more information there that we're going to use in a little while in another video. But as far as the router solicitation and advertisement, that's all there is to it. Now let's talk about this neighbor solicitation, because there's a rough equivalency here to something in version 4. The neighbor solicitation message itself, the NS, it's the rough equivalent of the version 4 ARP request. Now the main difference is that an ARP request asked for the MAC address of a single particular version 4 address. It said, okay, here's the IP address, 172.111, I need the MAC address of it. But a neighbor solicitation message asks neighbors found in the solicited node multicast address range of the destination version 6 address. It's asking them to reply with their link layer addresses. This leads us to the musical question, what the heck is a solicited node multicast address? Well, we're going to talk about that right now because this is not exactly one of those the name is the recipe deals. So let's take a few minutes and talk about this range. I have a feeling this is going to come into play on your exam. Edmund Kean, among others, has been credited with saying dying is easy, comedy is hard. And I've been credited with saying determining the solicited node multicast address for a given IP version 6 address is easy. Figuring out what the heck a solicited node multicast address is supposed to be in the first place is hard. Doesn't exactly roll off the tongue, but you get the gist of what I'm trying to say. We don't care why it's called a solicited node multicast address. We just need to know its purpose and exactly how it's derived, and it's very, very simple. But here's the deal with this address. It's a multicast that goes to other hosts on the local link. So far, so good. But not to all hosts on the local link, just the ones that have the same last 6 hex values as the destination IP version 6 address of the message itself. I kid you not. Now, this wasn't developed just to be funny or be a pain in the behind or create tricky exam questions, because for you on the exam, this isn't going to be tricky. There are version 6 services that actually rely on this address, and you'll bump into those as you continue your version 6 studies. For right now, we need to know what the address is. We've got that covered. But now we need to determine, or know how to determine, the solicited node multicast address for a given version 6 address. Easy as can be. This address has actually been staring us in the face the entire time on the router. And it's in the output of show IP version 6 interface. But let me show it to you, and then we'll come back and talk about how it's calculated. And that is it right there. That's it. That is the solicited node multicast address for this particular interface on this router. Now, you're probably looking at the last part of that and saying, that looks pretty familiar to me by this point. So let's see exactly what that is. Solicited node addresses always begin with FF02, then 2 colons, 1 colon FF. They always begin with that. To get the rest, all you do is grab the last 6 digits of the global unicast address and tack it right on the end of that address. And what are the last 6 characters of our global unicast address? Well, in this case, since we used EUI64, it's A4, F4, A0. And you just tack that right on the back of FF02, 2 colons 1, 1 colon double F, and you are done. That is it. See, nothing to it. Like I said, there are different theories about how we got this name for it in the first place, but we do not care about that. We just want to know how to derive it, and that comes into play with that neighbor solicitation. Now again, in version 6, the neighbor solicitation message, the source is going to be the link local address of host A. The destination will be the solicited node multicast address derived from the version 6 address of host B. Now you can see how this cuts down on overhead big time when compared to version 4's ARP, because this initial request for information, it's a multicast that's going to be processed by very few hosts on the link, where a version 4 ARP request, that was a broadcast, everybody had to stop and take a look at that. So this is a lot more efficient. After all that, it is time for a neighbor advertisement. That is simply the reply. Host B answers the neighbor solicitation with a neighbor advertisement, and the neighbor advertisement contains host B's MAC address. Host A pops that address into its neighbor discovery protocol neighbor table, which is the equivalent of IP version 4's ARP cache, and we're done. That's it. I think there are some serious exam points waiting for you with these neighbor terms, the advertisement, the solicitation, and the router solicitation in the advertisement, and the addresses that we looked at in this particular video. So make sure you're crystal clear on those before you proceed to DHCP in IP version 6, because we've got stateful DHCP and stateless DHCP to talk to, and we're going to see in action on the very next video. See you there.